Dhru, and this is my Lab 1 report for Physics 2212. This presentation focuses on the charge tapes experiment, a fundamental aspect of our course learning objectives. In this lab, we will be using tape as a model for point charges for observing electron transfer between surfaces, as well as to estimate the charge and quantity of electrons transferred. All the interactions between tape pieces will be simulated and visualized using the GlowScript program. It is worth mentioning that each tape piece possesses an evenly distributed charge. The fundamental concepts can be visualized into two pivotal points throughout this lab. The first being Coulomb's law, which states that like charges repel and opposite charges attract with a force that is proportional to the product of charges, along with Newton's second law, which occurs when a force is acting on an object that is equal to the mass of that object times its acceleration. In other words, if one of the tapes is free to move, it will accelerate towards or away from the other tape depending on the force. As shown, the model represents tape B as a system, while tape A acts as the surroundings. The initial mass, length, and width of the tape pieces were all taken into account within the GlowScript code. The results showed that the positive charge on the tape exhibited repulsion when they were near each other, and that the electric field was 1.02 times 10 to the 6 newtons per coulomb. Additionally, it was found that the electric force on tape A due to tape B was negative. So as we can see in the code snippet, the initial conditions and constants were established, followed by the code to visualize the particles. The gravitational force was then calculated, which took into account the calculations of the position vector, otherwise known as r, magnitude of r, and unit vector, or r hat. From this, I then calculated the electric field using the equation E equals F over Q, or electric field equals to force over charge, to find the total charge of 1.02 times 10 to the 6 newtons per coulomb on a single tape, as previously mentioned. In the case of static experiments like tape B, the effective air resistance is negligible compared to the electrostatic forces. Additionally, we do treat the long tape as though it were a point charge with all the charge concentrated at the center of the long tape. In other words, if the charge is uniformly distributed along the tape, the electric field at a point outside the tape can be approximately equal to the field produced if the entire charge were concentrated at the center. So we assume that each U-tape we made had about the same amount of charge, which would be evenly distributed along the length of the tape, since slight variations in the distribution or the amount of charge are unlikely to significantly affect the overall outcome of the experiment and the results. So some potential sources of error include inconsistent charging of the tapes. This could be due to differences in pressure, duration, even area of contact during the charging process can result in varying levels of charge. The tapes may also lose charge over time. This could be due to air humidity or even the proximity of other charged objects, which can alter the results. And this leads into the last one, which is contact with surfaces that causes a loss of charge. So every time the tape is touched or comes into contact with another surface, there may be charge transfer, which can alter the amount of charge on the tape and change the type of charge from being positive to negative. To answer the discussion questions, if the electrons had a positive charge and protons a negative charge, there would be no change. And this is because the fundamental principles of physics, such as Coulomb's law, don't depend on the actual sign of the charge, but rather on the relative differences in charge. So we're only looking at the magnitude of the charge. Because the nature of static electricity, charge can be lost or altered due to unintended variables that could affect the outcome of the experiment. And so this is caused by the loss of charge through conduction through human skin, which is why it's important to handle the pieces of tape with caution as to not affect the charge of it when it comes to contact with your own skin. It can also be caused by neutralization of charge, absorption of moisture from the air, or contamination with other particles. So that's it for my lab 1. Thank you so much for watching, and I hope you enjoy.